Next we'll do concentration cell. Now what is a concentration cell? Write the definition first. Concentration cell is a cell in which the two electrodes are of the same material, and the concentration of the electrolyte is different. In which the two electrodes are of the same material and the concentration of the electrolyte is different. Let us say you are having a cell which contains two zinc electrodes, same material, and the concentration of the zinc sulfate solution in the electrolytic solution is different. Let us say one is 1 molar, another is 2 molar. Alright? The definition can be in this way also. Read on. Concentration cell is a cell in which the electrodes are of different concentration, but the electrolyte is the same. In which the electrodes are of different concentration, but the electrolyte is the same. Alright, the first one we generally prefer, that is electrodes are of the same material and the concentration of the electrolyte is different. That means here you will be taking, that is, let us say I have taken this particular cell which contains a zinc electrode, and this is your ZnSO4 solution which is 1 molar, we can say that. And we have taken another cell we have taken it. It also contains ZnSO4 solution. This also contains ZnSO4 solution, but the concentration of the electrolyte is 2 molar, we can say that. And here the electrode is what? That is the same thing, it is a zinc electrode. It is being connected, what you can say, by the help, and here we are having a voltmeter attached to it, and here this is your salt bridge. That is your salt bridge. Here we are having a salt bridge. Yeah. Alright. Just a rough diagram I did it. So this is known as a concentration cell. We can say that. Fine. Now how to calculate the EMF of a concentration cell. Now you got it. What is a concentration cell? Now we will see how to calculate the EMF. Now here it can be in the same way also. Suppose we have used 2 hydrogen electrodes. Alright. 2 hydrogen electrodes. SHE. I have used it. And I have taken HCl solution of different concentration. And here I have used the SHE, the hydrogen gas electrode. I have used it. That also can be taken. Clear? Understood? Yeah. So now you see. So what I said, we will need to calculate the formula for concentration cell. We need to calculate the formula. So same thing, E cell is equal to. Now let me write first the equation. Zn slash Zn2 plus double slash Zn2 plus slash Zn. So this is your solid, this is aqueous, this is again aqueous, and this is again your solid. We can say that. So I can write it in this way. Let us say the concentration of this is C1, let us say, and the concentration of this is nothing but C2. Alright, C2, here it is. Considering that C2 is greater than C1. Now generally this is your oxidation electrode and this is a reduction, isn't it? This is oxidation potential, this is reduction potential. Generally where the oxidation takes place, the concentration is less, and generally where reduction takes place, the concentration is generally it is more. Why? Because always the current flows from higher potential to that of the lower potential. This is higher and this is lower. Clear now this particular thing? Fine. So Zn minus 2E minus, this one we are writing first, this one, see, gives Zn2 plus. Alright, so what is this concentration? C1. Next, in the second one, what is happening? Zn2 plus, what is its concentration? C2. Zn2 plus 2E minus will give you what? Zn. Now I am going to add it up. So what will happen? This zinc and this zinc also is going to cancel. If I am going to add it up, what will I get it? Here, see, Zn plus Zn2 plus gives Zn plus Zn2 plus gives Zn2 plus Zn. So does that zinc will get cancelled? Both are solid, na? Both are solid of the same electrode. They will get cancelled. And the concentration solid is how much? It is 1. So it will get cancelled. So what I am having it here? Zn2 plus, that is C2, gives Zn2 plus, concentration is C1. So this is your product and this is your reactant. Alright? Fine. Now I will put the value here. Alright? I will put the value. So I am rubbing it at the top. The first one I will rub it. to calculate the value of the E cell because I don't have the space here. So now see here, E cell will be nothing but E naught cell. So minus 0.0591 by N log concentration of product. So what is the concentration of product? It is nothing but C1. And what is the concentration of the reactant? It is nothing but C2. Concentration of product by reactant. Next equation. Now E naught cell is what? 0. Why it is 0? E naught cell is 0. Why? Because here the cathode is also zinc, anode is also zinc. So both will have the same electrode potential. Zinc will have the same electrode potential. So if you subtract it, cathode minus anode, it will be what? 0. Did you get my point? The cathode is also zinc electrode, anode is also zinc electrode. The zinc electrode will have the same potential or not? So if you subtract it, the value of E naught cell will be what? 0. So hence E cell is equal to, it is how much? Minus 0.0591 by N log C1 by C2. You will say, no sir, I want plus. Then what will I do? 0.0591 by N. Let us write 1 properly. Log C2 by C1. Log C2 by C1 in this way. Clear? E cell is equal to, this is the formula to calculate the E cell of a concentration cell. E cell is equal to 0.0591 by N log C2 by C1. If it is positive, suppose if you want to keep it negative, then the same thing is acha. If it is very in terms of pressure, alright, so what it will be? Alright, it's a gaseous electrode. E cell is equal to 0.0591 by N log P1 by P2, considering that P1 is greater than P2. P1 is the partial pressure. P1 by P2. P1 is the partial pressure. Is greater than P2. So hence it will be positive. If P2 is greater than P1, then it will be negative. Alright? Clear? So in this way, if it is pressure, then this is the formula. If it is concentration, then this is the formula for a concentration cell. I should say that. Okay? Now, I hope you understood the concentration cell. Next is a very important question to you. You know that a cell dies off, means a cell stops working after a certain time, isn't it? Whichever cell, dry cell, galvanic cell, Leclanc cell, mercury cell, any particular cell. Suppose the cell which you are buying it from the market, a battery. So is it lasting forever? No. After some time it stops working. Why? What is the reason? Why we are not able to draw current from that particular cell? What is the reason behind it? See, now when the cell is working, alright, when the cell is working, slowly and slowly the potential difference is what? Decreasing. The voltage is decreasing. Definitely, because when you are buying a new battery, alright, so you put it into your torch, you will see whatever the light you are getting it. So as you are going on using, the intensity of the light remains the same or not? Does it remain the same, the intensity of light? No. Intensity of light decreases. That means what? The potential difference decreases. That means what? The voltage decreases. So very simple thing. Whenever you are using a particular cell, whenever you are using a particular battery, the voltage goes on decreasing. And you know that always a current flows from higher potential to lower potential. That is from cathode to anode. Already we have studied this thing. Cathode to anode. Because cathode is higher potential, anode is lower potential. The difference in potential gives the EMF. So higher is the difference between the two electrodes, that's cathode and anode, higher is your EMF. Higher is the difference between the two electrodes, higher is the EMF. Alright, you know it, all these things? Now I will come to it. When you are using a particular battery, the concentration of the ions changes. Alright, listen carefully. When you are using a particular cell or a battery, the concentration of the ion changes. How? See here. Now I will show you graphically this one. So here I am taking in the x-axis that is time, and in the y-axis I am taking, that is nothing but reduction potential. I am taking it. Potential, yeah. And here that is I am taking, that is here E cell to be as 0. Means the value of E, the reduction potential to be as 0. This one is 0, I am taking to be as. Alright, the value of E is 0, or I can write it simply 0 here. So now listen carefully here. What I said, as the time progresses, the voltage goes on decreasing, and the concentration of the ions in the electrolyte also changes. So what you find is that as the time progresses, that is the concentration, that is of the electrons in the oxidation electrode increases, isn't it? let us say I am taking galvanic cell. This is a zinc electrode. You have taken it. Alright, and I have taken, this is your zinc sulfate solution. So, what will happen? Oxidation takes place, you know that? In zinc, oxidation takes place. So, in oxidation, what happens? Loss of electrons. Zn minus 2e minus, it gives Zn2 plus. So, this ions, this electron goes and sticks here. So, the concentration of the electrons in the, what you can say, anode goes on increasing. Concentration of the electrons goes on increasing. The concentration of the ions, electrons means the ions, goes on increasing. So hence what you find is that the concentration of the anode goes on increasing as the time progresses. The concentration of the ion is, see, it is increasing. Alright. Now, at the same time, in case of copper, what will happen? Suppose I am taking a galvanic cell here. Suppose here I am taking, that is copper. Alright, instead of zinc, now it is copper. Alright, I am taking cathode. I understood for the anode. Anode, what happens? The electrons goes on sticking the particular, what you can say, anode. As a result, the concentration of the ions increases. But at the same time, in copper, what will happen? The concentration of the ion is going on decreasing. Why? Because Cu2 plus 2E minus will give you what? Cu. So copper gets precipitated here. Copper gets precipitated. The concentration of the ion decreases. So the concentration of the ion is decreasing. In reduction potential, the concentration decreases. This is for copper and this is for zinc. And in case of zinc, it increases. Now, in this way, what will happen is that when zinc is increasing, the oxidation potential is increasing, reduction potential is decreasing. Alright, how it is? Here the concentration of ion increases in case of zinc, and in case of copper, it decreases. A point will come where both will meet together. Alright, a point will come when both is going to meet together. That is, concentration of zinc is going to increase, concentration of copper is going to decrease. The oxidation potential increases, reduction potential decreases. And what is this point called? Here the value of E cell is 0. How it is 0? Because both in this particular point, both are having the same potential. At this point, both are having the same potential. You can see here that zinc is increasing, copper is decreasing. So when it reaches a particular point, what happens? As you are going on using the battery, the voltage is decreasing. How it is decreasing? See here. Because the potential here it increases and here it decreases. So in this way, when they will meet, the difference in potential is what? 0. E cell is equal to E cathode minus E anode. Both are same. Cathode is also same, anode is also same. So hence value of E cell becomes 0. Due to which, when the value of E cell becomes 0, the cell attains equilibrium. And when the cell attains equilibrium, we are not able to draw any current from the cell. And hence the cell stops working. This is how the cell stops working after some time. Alright, when you are using a particular battery, why does the voltage decreases? Why does the cell stops working after some time? The reason I have said it to you, graphically I have explained it. Alright, why do I take reduction potential? Because I have said you that all the potential should be converted into reduction potential. When I say E cell is equal to E cathode minus E anode, both are at reduction potential, the cathode and anode, you know it. I have told you earlier. Alright, thank you very much.